Welcome to Poor Academy. I am Ashish. Today we will discuss MCQ on Matrix Part 3. In the previous two videos on MCQ on Matrix, I have already discussed with you 36 problems, and I will do another 35 to 36 MCQ in the next two video. This is Part 3. I will cover at least 18 to 19 problem in this video. I hope you have understood those video in part 1 and part 2, and if you don't have visited those videos, first watch video on MCQ, Matrix MCQ part 1, part 2, then study this. Now let's go to the go to the problem. So first problem of the part 3 video 37, we have already covered 36 problem in part 1 and part 2 on matrix. So 37 problem, if A equal to this is a symmetric matrix, then x, y, z are. So there are some unknown values x, y and z. So what are the values of x and y and z if the matrix A is a symmetric matrix? So if it is symmetric, then we will interchange the row and column, since it is a symmetric matrix. So this equal to, I can say 5 2x, y 2 minus 3, 4 z minus 7. So you see x equal to 4, x equal to 4, 4 also x in A and both E, B, and y x equal to 4, y is equal to 2, and z equal to minus 3, z is equal to minus 3. So correct answer is 4, 2 and minus 3. B is the correct answer. Next 38. A is matrix, this is a matrix, is the sum of a symmetric matrix B and a skew symmetric matrix C. So A matrix is sum of true matrix B and C. B is symmetric and C is skew symmetric. So we know a matrix can be expressed as sum of symmetric and skew symmetric matrix like this. This is equal to half into A plus A transpose plus half into A minus A transpose. So this one is symmetric and this one is skew symmetric matrix. So any matrix can be expressed as sum of a skew and symmetric matrix like this. Half into A transpose, it will be a symmetric matrix, and half of A minus A transpose, it will be a skew symmetric matrix. So here is given B is a symmetric matrix and C is skew symmetric. B is symmetric matrix. So B equal to this, because this part is symmetric. So how will calculate B? Half into B equal to half of A plus A transpose. So A plus A transpose, let's first calculate A plus A transpose equal to A this, so 6, 8, 5, 4, 2, 3, 9, 7, 1. This is A. plus A transpose, interchanging the rows and column. 6, 8, 5, 4, 2, 3, 9, 7, 1. If you add these two, we will get 12, 12, 12, 14, 12, 4, 10, 2, 10, 14. Now half of A plus A transpose, which is equal to B, is multiplying each element by half. So we will get into half 6, 6, 7, 6, 2, 5, 7, 5, 1. So which is the correct answer? 6, 6, 7, 6, 2, 5, 7, 5, 1. A is the correct answer. Clear? Because any matrix can be expressed as sum of symmetric and skew symmetric, and that symmetric matrix will be calculated as half of A plus A transpose. So we are interested in B here. So half of A plus A transpose is equal to this. So it is the correct answer. Next two problems are very easy problem. 39 says A is a square matrix of order 3 by 3. Ka equal to det of Ka. So for matrix, you know, if you multiply a matrix, suppose a matrix A, B, C, D. It is a matrix A. If you multiply A by K, so each and every item, each and every elements AK, BK, DK, CK, each CK, each element get multiplied by K. Each and every element. If a matrix is multiplied by K, each element is multiplied by K. Now if it is a determinant of like this AK, BK, CK, DK. So if I take common from any row, we have to we may take common from first row. So take common K, it will be A and B only. Each element of row only is divided by K, but this remains same. So if I again take K from this row, it will be K square. So C plus D, that means it is K square into A, B, C, D, A. So if it is of order 2, it will be if each element of a matrix is multiplied by K, that means K equal to, matrix become like this. And if you want to, this is the matrix and its Z value is K square, because it is order 2. If it is order 3, then from each row, for calculating determinant of Ka like this, from each element K is taken common. So there are 3 rows, so K cube A would be the correct answer. Since it is a order 2, K square. If it is order 3, then it will be Ka is equal to K cube into A, because we can take common from first row K, then again K for det. So it will be K cube. So correct answer is this, K cube A. Last 40, if A equal to 5, det A is equal to 5, determinant value of a matrix A is 5. What is the det of A inverse? So you know, I have already discussed in the video on matrix, if data is equal to 5, data of A inverse would be 1 by 5. So correct answer is C, 1 by 5. Next the problem 41, 42 and 43. You may try. So 41 correct answer is A. 42 correct answer is also A, and 43 correct answer is B. So let us try. So for correct answer 41, is a skew symmetric. For 42 A and for 43 is B. So 41 is very easy. It says the matrix, this matrix is A. What type of matrix is this? For a skew matrix, you will be able to easily identify a skew matrix. All the diagonal elements, leading diagonal is 0, and there is opposite sign but equal value. 5 minus 5, 7 minus minus 7, 7, 11 minus 11. So it is a skew symmetric. It is very easy. So correct answer is this. And for 42, we have to calculate 42. 42 says A is a matrix. 42 A is a matrix. Then A inverse is. So correct answer is A. So how we calculate? You know how to calculate A inverse. 1 by data, and then this is matrix of cofactor, matrix of cofactors, and its transpose. Then we will get A inverse. So first we have to do is the calculation data. So for data equal to 2 into minus 1, then 0, we may ignore 0, 3 minus 0, that is 0, plus 3 into 5 minus 0, that means 5. So minus 2 plus 15 equal to minus 13. So data is equal to minus 13. So for A, 1 by 13, 1 by 13, this is 1 by 13, 1 by 22. You may, the C cannot be the answer. So this is also 1 by 13. So out of 3, you may easily calculate cofactors of each element, giving sign plus, minus, plus, and you will find the correct answer, this one. But I will apply a shortcut method. You may calculate in detail cofactors of each element, then transpose it. But I will apply shortcut method. Let's see, identify where in these 3 matrix where the elements are different. Minus 1, same. 3, 3, no. Minus 3, 2, okay. There is also 2, no. 5, minus 5, 5, same. Minus 2, 2 and 5. So you see that this point, middlemost item, this and this, all are different. And if you transpose the cofactors, all the elements of the leading diagonal, this and this, their position doesn't change. If you interchange row and columns, the elements lying here of the elements of the leading diagonal do not change the position. So 2 is such an element, middle item, it will not change its position, but after transposing it will also remain here. So it is very good, we can calculate the middlemost cofactors. So what is the cofactors of this matrix? Middlemost. So I have to ignore the second row and the second column. So what is the value of cofactor? Plus, minus, plus, minus, plus. So this is also plus. So plus, it gives 2 into minus 1, minus 2. 2 into minus 1, minus 2, minus 0. That means minus 0, that means minus 2. And here sign is also plus. So here second middlemost will be minus 2. So minus 2 is this is the correct answer, because minus 2 is the middlemost item if you make a matrix of cofactors. If you make matrix of cofactor, the middlemost item will be minus 2. The middlemost. Ignore you give a strike first second row and second column. Then 2 into minus 1, minus 2, minus 0, so minus 2. And after, if you transpose this, the middlemost, the position of the middlemost element will not change. So A is the correct answer. So with applying shortcut method, I am able to calculate the correct answer. Next, x, y, z are non-zero. That means non-zero, not zero, not non-zero real number. Non-zero real number. Non-zero real number. Then inverse of this. This is the matrix. What would be its inverse? So how will calculate inverse? First, date A. Suppose A is equal to x 0 0 0 y 0 0 0 z. So what is date A? Date A equal to x into yz minus 0. So and here is 0 0. So date A is x y z. Now we have to calculate the cofactors. So matrix of cofactors. So A inverse equal to 1 by date A equal to matrix of transpose of the matrix of cofactors. I will calculate cofactors. Plus, minus, plus, minus, plus, minus, plus, minus, plus. So for this element, first row, first column, you may ignore. So yz, yz, yz minus 0, yz. So for second, this into this, 0 minus 0, 0. So this is 0. Third, 0. So all this will be 0. Second element, middlemost, yz plus yz, 0. This is 0, this is 0, and for this element xy plus xy. This is the matrix of cofactors. If you transpose it, you see, if you transpose it, it becomes a symmetric matrix. If you transpose this, it will remain same. So let's see, 1 by date A is 1 by x, y, z. Then transpose yz 0 0 0 y 0 yz yz comes twice, yz this xz. I made mistake. If you cover this second row and second column, xz minus 0, xz 0 0 0 xy. If you divide each element, it becomes, if you divide each element by x, y, z, you will get 1 by a yz by x yz, so 1 by x, that means x to the power minus 1, 0 0 0, and xz by xyz, each element will be divided by xyz, so 1 by y, that means y to the power minus 1, 0 0 0, here it will be z to the power minus 1. So correct answer is B. Clear? Next fourth problem, you try pausing the video. So for 44 correct answer is D, and for 45 correct answer is B, 0, and 46 the correct answer is C, 1, and for 47 correct answer is 0. This is determinant, not matrix. So correct answer 47 is A. So there is space problem. Though first let us solve 44. 44 says A equal to 1 sin theta 1. So blah blah, this is A. So what is its determinant value? The correct answer is 2, 4. So I can write here date is the element of 2, 4, including 2 and 4, because it is within the range 2 and 4, including 2 and 4. So first we will have calculate date A. So date A equal to 1 into 1 minus sine square theta, so plus sine square theta, then sine theta minus sine theta into this row, this column, and this row. So minus sine theta, 1 is minus sine theta into 1, so minus sine theta minus sine theta again, so plus sine theta, plus 1 into this sine theta minus sine theta into sine theta, sine positive sine square theta minus 1, so plus 1. So this cancel, this equal to 1 plus sine square theta plus 1 plus sine square theta, that means 2 plus 2 sine square theta. You know sine theta is less than equal to 1, and it is within minus 1 and plus 1. So if there is sine square theta, so sine square theta must be positive, greater than 0. So I can write it is less than 1, squaring both sides, this 0. It is greater than 0 but less than 1, because it won't have minus value. So now 2 sine square theta, so if I multiply both sides, 0 into 2, 0, and 1 into 2, 2. And here is 2 plus 2 sine square theta. So 2 plus 2 sine square theta, we add 2 both sides, 2 plus 2 here, 0 plus 2. So it becomes 2 less than 2 plus 2 sin square theta less than equal to 4. So 2 plus 2 sin square theta is less than equal to 4 and greater than equal to 2. So the determinant value lies between 2 and 4. So the correct answer is 2 to 4 including 2 and 4 because equal sign is also here. Clear? Now next problem 44. Says this is a matrix, this is a determinant, sorry, it is a determinant and its value is equal to 0. Why? Because take common from this row, you will get take common b minus a, here you take a, b minus a, here you take c, b minus a. Clear? And here it is b minus c, a minus b, c minus a. Take common c, b minus a, b minus a, b minus a. Now I can take b minus a common from this column and from this column. So it will be b minus a whole square. B minus a whole square. The remaining b a c, b minus c, a minus b, c minus a, c, b, a. Now b minus a whole square. Now do one thing, from first column we deduct all the elements of the third column. So C1 dash is equal to C1 minus C3. So it becomes b minus c, a minus b, c minus a. Second row, second column, b minus c, a minus b, c minus a, c, b, a. You see the first column and second column is same. So it is a property of the determinant. If two columns are same, the value of determinant is 0. So it is equal to 0. Correct answer is B. Next, distinct root of this. Distinct root means how many value of x. Distinct root of x means how many value of x there are. So how many value of this is determinant. I'm sorry, this is not matrix. This is get A, determinant value. So how number of distinct root of this is equal to this in the interval x less than pi by 4 greater than minus pi by 4. So I can do one thing. So we add all the elements of the row in the first column. All the elements of the row are added. I can say that C1 equal to C1 equal to C dash 1 equal to C1 plus C2 plus C3. So we will get sin x plus 2 cos x. Sin x plus 2 cos x. Sin x plus 2 cos x. Cos x cos x, cos x, sin x, cos x, cos x, sin x. It's equal to 0. Now take sin x common, sin x plus 2 cos x. 1, 1, 1 cos x, cos x, sin x, cos x, cos x, sin x. Clear? Now you calculate. This equal to sin x plus 2 cos x into 1 into sin square x minus cos square x, sin square x minus cos square x. Minus this sin x cos x, sin x cos x, sin x cos x minus cos square x. So it will be plus. And last plus cos square x minus sin x cos x. Sin x plus 2 cos x, sin square x minus 2 sin x cos x plus cos square x is equal to 0. So sin x plus 2 cos x is equal to, this is sin x minus cos x whole square equal to 0. So either sin x plus 2 cos x is equal to 0. So here you will see that tan x equal to minus 2. So tan x is equal to minus 2, x is equal to tan inverse minus 2, it becomes 63, but approximate 63. So but x lies between pi by 45 plus 45 minus 45. So 63 cannot be. But here if you see sin x, here you see if this is equal to 0, so tan x is equal to minus 2. Therefore x equal to approximate 63 degree, but it is not correct because pi lies between 45 degree, plus minus 45 degree. But here if sin x minus cos x whole square is equal to 0, that means this is equal to also 0. So sin x is equal to cos x. Sin x is equal to cos x, or tan x equal to 1. So when tan is equal to 1, so x equal to pi by 4. So there is only one solution, x equal to pi by 4. So C is the correct answer. There is only one single solution, 1. If it lies between pi and plus pi minus pi, then there will be two solutions. One is this pi by 4 and another is 63 approximate when tan x is equal to minus 2. So then answer would have been 2 correct answer, 2 roots. But here since x lies between plus minus pi by 4, so correct answer is 1. 47 is also very easy problem, but ABC are the angles of the theta, determinant. So ABC are the angles. So this is the determinant. So if I expand the determinant, so minus 1 into 1 minus cos square A, then minus C minus cos C minus cos A cos B plus cos B cos A cos C minus cos B, that means plus cos B. So if I simplify, minus 1 minus cos square is equal to minus sin square A, and I take common, so it becomes plus cos C plus cos A cos B, and this is cos B cos A cos C plus cos B. So I have simplified it. Now ABC are the angle of a triangle. ABC the angle of a triangle. Since so A plus B plus C equal to 180 degree. Angle of sum of angles of triangle. So A plus B plus C equal to 180 degree. So you see there is cos A cos B. So I have kept A plus B here and transferred C 180 minus C. So cos A plus B is equal to cos this, cos A 180 minus C, that means it is in the second quadrant. So cos is negative. So this equal to cos minus cos C. And if I expand this, cos A cos B minus sin A, it is identity formula or trigonometric formula. Cos A cos B, if there is plus, here it will be minus sin A sin B equal to minus C. And if I take cos C there, plus cos A cos B plus cos C is equal to, I am taking this sin A sin B. So I have calculated this portion, cos A cos B plus cos B is equal to sin A sin B. So similarly now I put the value minus sin square A plus cos C into this sin A sin B, okay, plus cos B into cos A cos C plus sin A sin B. Similar in this way, similar way, if I take A plus C is equal to 180 minus B, we will get cos A cos C plus cos B is equal to sin A sin C. Same. So if I put this sin A sin C, so now this equal to minus sin square A. Now I take common sin A plus sin A. I am taking common sin A from these two. So this become sin B sin C, sin B cos C, sin B cos C plus cos B sin C. Clear? So this equal to minus sin square A plus, so sin A cos B plus cos A sin C equal to sin B plus C formula. So this equal to sin B sin A into sin B plus C formula. I repeat again, minus sin A square plus sin A, and this is sin B cos C plus cos B sin C is equal to sin B plus C formula, sin B plus C. Now the last part, last part minus sine square A plus sine A sine B plus C. So you see B plus C equal to 180 minus A. 180 minus A, these are angle. So sine B plus C equal to sine 180 minus A. So equal to, it is second quadrant, sine positive, sine A. So sine B plus C equal to sine A. So now I can write this minus sine square A plus sine A, and sine B plus C is just sine A. So sine square A. So minus sine square A plus sine square A equal to 0. It is the hardest problem and a very lengthy problem. It should not come in the exam, but it is given in the NCERT problem, so I have solved it. Clear? Next, fourth problem, 48, 49, 50, 51. So if you try, pause the video. Okay, the correct answer for 48 is A. For 48A. For 49, the correct answer is C. And for 50, correct answer is 5A. Correct answer is A. And for 51, correct answer is C. 128B. So let's start. First problem, answer is half. Answer is A, half. So let us solve the maximum value of the determinant. This is the determinant value sign, the maximum value of this determinant. I will calculate maximum value. You see, if I from first all the elements of the first row, I deduct the elements of the third row. That means R1, R dash 1 equal to R1 minus R3. So I will get the new determinant 1 minus 1 plus cos x. So it becomes 1 minus 1 0 minus cos theta. Minus cos theta, 1 minus 1 0, 1 minus 1, to get maximum 0. Then 1 plus sin theta, 1 plus cos theta, 1. So now its determinant value minus cos theta into 1 into this. That means 1 plus sin theta minus this, minus 1. 1 cancel. So you will get minus sin theta into cos theta. We can take half, multiply half product into 2. So you got 2 sin theta cos theta, that means minus half sin 2 theta. So what is the value of sin theta? Maximum value sin theta. I am rubbing this portion. Maximum value of sin is plus minus 1. Sin 2 theta maximum value is this. So this is equal to minus half sin 2 theta. So sin 2 theta lies between less than 1 minus 1. So maximum value is plus 1, minimum value is minus 1. But here is minus sign is there. So we will have to apply the minimum value. Then after multiplying minus negative value, it will become positive. So maximum value we will get. So its maximum value is minus half into minus 1. Equal to half is the maximum value. So the correct answer is half. Next is very interesting problem. Oh, is a to the power 2022 new year 20 power. If A is a matrix, it is a matrix sign. There are two signs of matrix, either this or this. So A is 1 1 1 1. Then A to the power 2020 is equal to 2 to the power k into A. What is the value of k? So k is equal to 2021. How? Let's see. A square is equal to A into A. 1 1 1 1 into 1 1 1 1. So matrix multiplication 1 1 into 1 1 plus 1 plus 1. Here 1 plus 1 1 plus 1 1 plus 1. This becomes, I can take 2 common, 1 1 1 1. So it becomes again 2 into A. So we get A square equal to 2A. And A cube equal to 2A square. 2A square equal to 2 into A square equal again 2A. So 2 square A. So you see, when cube power of 2 is 1 less 2 and A comes. Everywhere if you go on in this process, in this way you will get power of 2 would be 1 less than power of A and A will come. So now we have to value A to the power 2022. So power of 2 is K. So K is 1 less 2021 and A will come. So correct answer is C. 20 K is 2021 1 less. Next, A equal to this and B equal to a matrix given. And a relation is given, identity A plus B equal to A square plus B square. A plus B whole square equal to A square plus B square. So I can write A square, if you expand, A square plus AB plus BA plus B square equal to A square plus B square. I cannot write in case of matrix A square plus 2AB plus B square because A and B is not equal to BA. Yes, these two are different. So I have to write once AB and then BA. So if A square plus AB plus BA plus B square is equal to this, so A square cancel, B square cancel. So AB plus BA equal to 0 or AB equal to minus BA. Okay, so we know AB is equal to minus BA. Now, so what is AB? So AB equal to this into this, 1 minus 1, 2 minus 1, x 1, y minus 1 equal to 1 into x, x minus 1 into y, x minus y, then 1 into 1 minus 1 into minus 1 plus 1 into 1 minus 1 plus 1, 2 into x to x minus 1 into minus y, 2 into 1 2, and minus 1 into minus 1 plus 1. This is AB, and minus BA equal to minus of BA, x1 y minus 1 into 1 minus 1 2 minus 1 minus this minus x into 1 x 1 in x into 1 1 into 2 plus 2 x into 1 1 to 2 x into minus 1 minus x minus 1 minus x minus 1, and now y minus 2 y minus 2 minus y plus 1. And if I insert minus everywhere against each element, so minus x minus 2 x plus 1 2 minus y 1 minus 1 plus y. This, so from this I get that this equal to this equal to this. So I can write x plus 1 equal to 2, x plus 1 equal to 2, so x equal to 1. So I have got one value x equal to 1. And for y, 3 equal to minus 1 plus y. So y is equal to 4. So x equal to 1, y is equal to 4. So x plus y is equal to 1 plus 4, 5. 5 is the correct answer. Clear? Now this problem is also good problem. What it says? 51. A is equal to I minus I minus I. I is root over minus 1. That means it is cube root of 1. Imaginary value of cube root of 1. I square equal to minus 1. I square equal to root over minus 1. So I square is I is equal to root over minus 1. So I square equal to only minus 1. So A is equal to this, B is equal to this. 8 is equal to. So correct answer is C, A to the power 8. So A equal to, I am taking common I. 1 minus 1 minus 1 1. So A square equal to A square equal to I square into minus 1 1 minus 1 minus 1 1 into 1 minus 1 minus 1 1. This is equal to A square means minus 1 minus 1 1 into 1 1 into 1 1 plus 1, then 1 into minus 1 minus 1 minus 1 into minus 1 minus 1 into 1 minus 1 1 into minus 1, and here minus 1 into minus 1 1 into 1 plus 1 is equal to minus 1 into I am 2 minus 2 minus 2 2 If I take common 2, minus 2, 1, 1, minus 1, 1. So it becomes minus 2 into B is this. B is this. B is 1 minus 1, so is equal to 2B. Clear? So A square is equal to 2B. Then A to the power 4, A to the power 4, A to the power 4 equal to minus 2B. A to the power 4 means A square to the power, then this whole square. Okay. So we will get 4 and B square. Clear? And now B equal to 1 minus 1 minus 1 1. So B square equal to into 1 minus 1 1 minus 1 1. You will see I have already multiplied these two same, and I have got this answer. This into this equal to B square equal to B square equal to 2B. B square equal to 2B. Or if you multiply it, you will get this 2B. So if B square is equal to 2B, so I can write 4B square is equal to 4 into 2B. 4 into 2B means 4 into 2B is equal to 8B. 8B. Now again A8. A8 means A4 then whole square equal to A to the power 8. We are required this 8 value. So again whole square. So 8B whole square equal to 64B square. Again B square equal to 2B. That means 64 into 2B. That means 128B. So correct answer is C. 128B. Clear? A8 equal to 128B. 52, 53, 54, 5. Last 4 problems of part 3 video on matrix. So let's solve. If A square minus A plus I means identity matrix equal to null matrix, then A is equal to. So in this type of problem, we will pre-multiply each term by A inverse. Then we will get A. So A inverse into A square, I can write A into A minus A inverse into A plus A inverse into I equal to null. So A into A inverse I into A. I means identity matrix into A. So identity matrix into A means A. This is minus I inverse into A identity matrix and plus A inverse into identity is equal to A inverse equal to 0. So sorry, there is a mistake in the problem. A inverse equal to. So A inverse, this is very A inverse. So A inverse equal to I minus A. So correct answer is here. Okay, there is a mistake, you correct. It is A inverse, then A inverse equal to I minus A. Clear? Now total number of 2 by 3 matrices with each entry with 0, 1, 2, 0, 1 or 2. Suppose this is a matrix 2 by 3 matrix. That means row is 2. This is 2 by 3 matrix. There are 2 row and 3 columns. So this is 2 row and 3 column, 2 by 3. Therefore in total there are 6 elements, and each element can be each entry can be made with 0, 1 or 2. So that means in 3 ways. Each element I can write either 0 or 1 or 2. So this element can be 1, 0, 1 or 2. That means in 3 ways. Again this may be 0, 1 or 2, 3 ways. This is 3 ways, 3 ways, 3 ways, 3 ways. So total number of ways 3 into 3 into 3 into 3 into 3 into 3. That means 3 to the power 6. 3 to the power 6 means 81. 3 to the power 4, 81 into 9 equal to 9, 729. So 729 is the correct answer. Had it been given that it is a 3 by 3 matrix, 3 by 3, that means total number of total number of elements should be 3 by 3, 9. And if it is asked there only 0 and 2, so each element can be filled with these two, either 0 or 2. 2 is not given, 0 or 1. So this is 2 ways. So there are 9 elements, 2, 2, 2, 2 into 2 into 9. Therefore we are multiplying 9 2's. So answer would be in that case 2 to the power 9. But here if 3 elements are given, then 3 to the power 9. Clear? Now 54 is a very halwa problem, very easy problem. 52 says A is a skew symmetric matrix. So date. For a skew symmetric matrix, you will see in my video that date of a skew matrix is always 0. So A is the correct answer. So 55, the last problem, ABC is a B plus C, C plus A is equal to. Before doing this problem, let us give you the identity. You know, but you have forgotten. A cube plus B cube plus C cube minus 3ABC equal to A plus B plus C into A square plus B square plus C square minus AB minus BC minus C. This is the identity. A cube B cube plus C cube minus 3ABC. So here this is a matrix, this equal to. So let me write the matrix. Determinant ABC, BCA and CAB. This is a determinant. What is its value? So if I add, what will get? Suppose I am adding all items, A plus B plus C, A plus B plus C, A plus B plus C. This first, then B, C, C, A, B. Taking common, A plus B plus C, 1, 1, 1, B, C, C, A, B. Clear? Now I am interested in calculating its value. A plus B plus C so this equal to 1 into 1 into 1 into BC minus A square. Then minus 1 B square minus AC. Then plus 1 AB minus C square. So this gives A plus B plus C into UC minus A square minus B square minus C square plus BC plus AC plus AB. Clear? If I take minus common from this, minus A plus B plus C into A square plus B square plus C square minus AB minus BC minus CA. So it is, this portion is identical to this. Now you see, this is our first formula identity. A plus B, this is equal to minus AQ plus BQ plus CQ minus 3ABC equal to 3ABC minus AQ minus BQ minus CQ. So correct answer, it is no. This is no. AQ BQ minus 3C is no. So ABC minus AQ BQ should be. So D is the correct answer. In this part 3 video, I have completed another 19 problems, total 55 MCQs on matrix. I hope you have understood all the MCQs and you have enjoyed it. If you like this video, you share the video to your friends, relatives and your students for more and more circulation, and you must give like and subscribe to my channel. Thank you very much.